Now, this is a 6-mark GCSE chemistry calculation question. And the reason it's worth so many marks is because they've given us the masses of both of our reactants. And then we need to determine the maximum mass of this product in particular, the copper, that we can make. Which means that first we need to find out the limiting reactant, because the limiting reactant tells us how much product we can make. Because we can't make more than the least we've got, right? So, of course, we're going to start by calculating the moles, because when in doubt, find the moles, okay? So we've been given the mass of the aluminium, the mass of the copper chloride. So we'll start by finding the moles of each, which is mass over MR. Now, in the question, they give you all of the AR and the MR values that you need, so the relative atomic masses, relative formula masses. In the interest of space, I haven't put them here, but I'll just give them to you as we need them, okay? So for aluminium, that's going to be 108 as the mass, divided by the relative atomic mass of 27, which gives us 4 moles. And then for our copper chloride, that's going to be 1.21 kilograms. We should definitely turn that into grams first. So 1,210 grams divided by 134.5. Again, that value, which is the MR for copper chloride, is given to you in the question. And we end up with 8.996, which is basically 9, right? Now we've got the moles, we need to figure out which one is the limiting reactant, so which one we don't have enough of. Now, because these aren't reacting in a 1-to-1 ratio, it's not quite as simple as just looking for which one is the smallest. What we can do, we can look at this a couple of different ways. One way is just by looking at the ratios in the balanced symbol equation. This is reacting the aluminium and the copper chloride in a 2-to-3 ratio. 2-to-3 ratio, which means if we've got 4 moles of aluminium, then we should then need, so 2 double to 4, so we should then need 6 moles of copper chloride. But because we've got more than 6 moles, that means that the aluminium must be limiting, or the copper chloride is in excess. Now, a way that I like to do it, because it works every single time, even if your numbers aren't particularly friendly, is just divide each of these numbers by the coefficient, because then that kind of makes our ratio a false 1-to-1 ratio. So we'll take our 4, we'll divide that by 2 to give us 2. We'll take our 9, we'll divide that by 3 to give us 3. And so now we can see really clearly 2 is smaller than 3. So the aluminium must be our limiting reactant. And remember, our limiting reactant, that's going to tell us how much product we can make. Which means I'm going to get rid of this bit because we don't need it anymore, okay? Take a mental snapshot. I'm taking it away. Now we know aluminium is limiting. We can now use the moles of aluminium to tell us how much copper we can make. So we'll look at our ratio from our moles of aluminium to our copper. That is a 2-to-3 ratio, which means to find our moles of copper, we're going to divide by 2 and then times by 3. So 4 divided by 2 times by 3 gives us 6. Okay, so we have got 6 moles of copper. And then to find the mass is equal to Mr. Moles. So our MR, again, given to us in the question, is 63.5, multiplied by the number of moles that we just calculated, 6, which gives us 381 grams as our final answer. Okay, 6 marks again for this calculation. Moles, finding the limiting, using the ratio, and then finding the mass for your final product. Wow. Okay. If you want more practice for this type of question, then let me know and make sure you're following so you see them when I do them.